Hi everyone. Today the topic is VLE at low to moderate pressures. Generally, a number of industrially important processes bring two phases into contact. When the phases are not in equilibrium, mass transfer occurs between the phases. The rate of transfer of each species depends on the departure of the system from equilibrium. In most industrial processes, the coexisting phases are vapor and liquid. So now we study about the nature of equilibrium. Equilibrium is a static condition in which no changes occur in the macroscopic properties of system with time. This means the balance of all potentials. There will be balance of all potentials which may cause change. Now consider a system containing fixed amount of chemical species and also consisting of liquid and vapor phases in intimate contact is completely isolated. Then there is no further tendency for any change to occur within the system. In this case, the temperature, pressure and phase compositions reach final values which remain fixed. Then the system is in equilibrium and there is no net transfer of material between the phases. So in this we study about the phase rule and also Duhem'S theorem. For studying the phase rule, the first thing we have to know about is degrees of freedom. The number of phase rule variables which must be specified to fix the intensive state of system at equilibrium is called degrees of freedom F. So this is the difference between the total number of phase rule variables and the number of independent equations which can be written connecting these variables. So here the intensive state of a PVT system containing n chemical species and pi phases in equilibrium is characterized by temperature T, pressure P and n-1 mole fractions for each phase. So these are called phase rule variables and their number is 2 plus n-1 into pi. So here we are considering n chemical species, pi phases, so which are characterized by temperature T, pressure P and n-1 mole fractions. So temperature and pressure represent two variables plus n-1 mole fractions into pi phases. So the phase equilibrium equations which may be written connecting the phase rule variables are given by the equations mu I power alpha is equal to mu I power beta, which is also equal to mu I power pi. So here I is 1, 2 and so on n. Similarly, fi cap power alpha, fi cap beta, which is equal to fi cap power pi. So here also I is equal to 1, 2 and so on n. So here these equations contain pi minus 1 into n independent phase equilibrium equation. So here the fugacity and the chemical potential are the equations we are writing here. So these are equations connecting phase rule variables because chemical potentials and fugacities are functions of temperature, pressure and composition. So now the difference between the number of phase rule variables and the number of equations connecting them is nothing but degrees of freedom. So here F is equal to 2 plus n-1 into pi minus pi minus 1 into n. So now this equation reduces to 2 plus n pi minus pi n plus n. So that simplifies into F equal to 2 minus pi plus n. So this is the equation for calculating the degrees of freedom F. Next one is Duhem'S theorem. So this theorem applies to closed systems for which extensive state as well as intensive state of the system is fixed. So here the state of such a system is characterized not only by 2 plus n minus 1 into pi intensive phase rule variables but also pi extensive variables. So here both intensive phase rule variables and extensive variables must be considered. So the total number of variables is 2 plus n minus 1 into pi plus pi, which simplifies into 2 plus n pi. So if the system is closed and formed from specified amounts of chemical species present, then we can write a material balance equation for each of the n chemical species. So the total number of independent equations in addition to pi minus 1 into n phase equilibrium equations. So the total number of equations is pi minus 1 into n plus n, which is equal to pi n. So the difference between the number of variables and the number of equations is 2 plus n pi minus pi n, which is equal to 2. So on this basis, Duhem'S theorem is stated as, for any closed system formed initially from given masses of chemical species, the equilibrium state is completely determined when any two independent variables are fixed. So if you fix any two independent variables, then the equilibrium state is completely determined. So here the two independent variables may be either intensive or extensive. So when f equal to 1, at least one of the two variables may be extensive, and when f equal to 0, both must be extensive. So this is about phase rule and Duhem'S theorem. So this is the today's video. So if you like, please subscribe and share my videos. Thank you.